All right, let's do a quick review of naming because I think a lot of the note cards, or almost all of them, had a lot of questions about wanting naming practice, and so I thought I would also do a little bit of a naming review. And so when you're naming, really the thing that you always want to do is you're always going to start by looking at your first element that's in the name. Because really, the first element tells you everything you need to know. And you have 4 options for what that first element will be. So either it will be a metal that is a main group metal, meaning 1A, 2A, or 3A columns. And there was a really good question that I saw in the note cards, which was, what do we do with the metalloids? And it depends on which column they're in, but essentially the metalloids will behave like the normal metals or the transition metals, depending on where they are. And because I didn't ask you to memorize any names past element 36, you won't have to worry about those a ton. So if you have a metal as your first element, the only option for your second element is going to be either a nonmetal or a polyatomic. And so we're always going to name those in the same way. But if it is a metal, then you know it's going to be ionic because there's no possible compounds where you have a metal plus another metal. Another choice for your metal might be a transition metal. And if your metal is a transition metal, it will also be ionic. If your first element is a nonmetal, then it will only be paired with another nonmetal and it will be covalent. And your other choice for your first element is going to be hydrogen, which tells you that it's an acid. All right, so if you have a metal and it's 1A, you will not use prefixes and all you will do is name your metal. If you have a transition metal, again, no prefixes, you will just name the metal, but you'll also name the charge of it. If you have a nonmetal, then you know you're going to be using prefixes. And if you know you have an acid, then you will be using the word acid to name it. So let's go over what all of these things might be paired up with and how we would name the entire thing. So if you have a metal, the only thing it will be paired up with is a nonmetal atom or a polyatomic. You know what, I'm just going to rewrite this a little bit differently so it's easier to understand. So its partners can either be a nonmetal atom or it can be paired up with a polyatomic. If it is paired up with a polyatomic, then all you're going to do is name it. And you know that it's a polyatomic because it's going to have an 8 or an ite ending. And if you're given a name with an 8 or an ite ending, you know that what you're going to draw or write for the formula is going to be a polyatomic. If you have a nonmetal atom, then what you're going to do is name it, but you're going to change the ending to "ide." Okay, so you're going to use that "ide" ending. And if you see an "ide" ending and you're trying to get a formula from it, then you know that it's a element by itself, so a nonmetal atom rather than a polyatomic. So let's do an example, both going from a formula to a name and a name to a formula. So let's say that I want you to name sodium nitride. I give you the name sodium nitride and I want you to write me a formula. So the "ide" tells us that it's an element rather than a polyatomic. Okay, and so we'll write the sodium ion with the +1 charge, and nitride means that it's nitrogen by itself, not the polyatomic, and because it's in the 3A column, it has a -3 charge. And then we'll swap the charges, and that will give us the formula, Na3N. Now let's do another example where I will have you name give me the formula, or I'll give you the formula and I want you to give me the name. So let's say I give you the formula of Na2S. That means the name will be sodium with no charge, and then sulfur is an individual atom, so we'll name it sulfide. Let's see how that's different if I pair sodium with the polyatomic. So this is a polyatomic, and the name of the polyatomic is sulfite, so this is sodium sulfite. And notice how it's different because it's got the ite ending, which tells us it's a polyatomic, versus the ide, which is an individual atom. Now what if I gave you the name sodium sulfate? Now that 8 tells us that it was a polyatomic, and the polyatomic is SO4 2-, and so if it's paired up with sodium, we do our swap and we get an Na2SO4. All right, now let's see what we do if it's a transition metal. So with a transition metal, it's always going to be paired with one of the same things as a regular metal. So it will either be paired up with an atom, and so if we have and again, it's going to be a non-metal atom, and again, we're going to name the atom, and we're going to give it the ide ending, or it can be paired up with a polyatomic. So if I start with, and again, we're just going to name it, if I start with the name, right, and I give you the name something like chromium 3 chloride, again, that ide tells me it's an individual atom. So I will write chromium with its +3 charge. I know that chlorine as an atom, when it becomes an ion, gets the -1, so the chloride is the -1, and then I swap them, so I get CrCl3. What if I want to go the other way? So if I want to go from a formula to a name, so let's say I have Mn NO3 3. So NO3 is nitrate. I know that manganese is a transition metal, so I'm going to have to figure out what charge it has based on what it's paired with. Since nitrate is a -1 ion, but there are 3 of them, that gives -3 from it overall. So that means that manganese has to give me +3 so that I have a neutral compound. So I know the name of this is going to be manganese 3 nitrate. Let's see how it's different if we pair it up with just an element. So Mn, let's try O2. So if I have MnO2, I know that oxygen is a -2 ion, and there are 2 of them, so that gives me -4. So that means for manganese, I'll have to have +4. So I'll name this as manganese 4, which is IV, but if you drew 4 lines, that would also work. And then I'll do oxide, because it's an oxygen atom. But what if I want to do something fancy and put it with a polyatomic? What if I want to do MnCO3 2? Now, actually, let's make it more exciting. MnCO3 3. Aha! Now, CO3 is a -2 ion. That gives us -6. So that means manganese has to be +6. So this is manganese. Oops. Manganese 6, which is Vi, and now we're going to name the polyatomic carbonate. Or going the other direction, so let's say I give you a name, and I say we have, I'm just going to stick with manganese. Manganese 3 phosphate. Now I'm going to write out what I have. It's got the 8 ending, which tells me it's PO4 3 minus, and the manganese is also 3. So when we swap them, this gives us Mn3 PO4 3, but with ionic compounds we always want the smallest ratio, so we'll just make it Mn PO4. So that's everything ionic. Now let's talk about if we start our molecule with a nonmetal. So if we start with a nonmetal, we know that it can only be paired with a nonmetal. It will be covalent, and we'll use prefixes for everything. So if we have a nonmetal as our first element, it can only be paired up with another nonmetal, because that's how covalent compounds are formed, and there is no option to write the nonmetal first and then the metal. It's just not a notation we allow. So we will do a prefix with the name of our first one and a prefix with the name of our second one, and then we will still use the "ide" ending, because that's just how we always do it. So the name will have the "ide" ending. So let's do an example. So we'll do maybe PF4. So this is where we're going to name our phosphorus first, and mono is the only prefix that we can do on the first element where it's not necessarily required. So monophosphorus, tetra, and we change our fluorine, which is the element, and we make it fluoride. Let's go the other direction. Let's say I say we have carbon disulfide. So that means we have carbon. We just have one of them because the mono is optional. And then disulfide means sulfur, but you have 2 of them, so CS2. So we don't have to do anything with charges at all when we have a covalent compound, because we're just interested in how many of them we have. And our last thing that we have for naming is an acid when you have H in front. So when you have H in front, it's going to be an acid, but there are 2 kinds of acids. We can have H plus an element, and that's when hydro goes out front. So it'll be hydro plus the element name, and you change the ending to ic acid. Or our other option is we have H with a polyatomic. You don't use hydro, and any polyatomic that's 8 goes to ic acid, and any polyatomic that's ite goes to us acid, and vice versa. So if you have something that's us, you know it came from an ite ion. Let's do a bunch of examples. So let's say, for example, that I wrote hydrofluoric acid. Because we have hydro in front, that tells us that it's just H with one other element, and the element is fluorine. And since they're both plus 1 or minus 1, when we write the formula, it's just HF. Let's do another one. Let's say we have nitric acid. Ic acid with no hydro in front means that it came from nitrate ion. Now nitrate ion is NO3 minus 1, and H that goes out front is plus 1. So when we swap, we just get HNO3. What if it's something like phosphoric acid? Phosphoric acid came from phosphate ion. So phosphate is PO4 minus, H is +1, so when we do our swap, we get H3PO4 to balance out the charges. Or let's say we want to go from a formula to a name. So let's say I have H2SO4. This right here is the sulfate ion, so it's sulfuric acid. That's the only one that's kind of a weirdo where we put the in there. So that's just something we try to remember. Let's do another one. What if we have H2SO3? Now this ion is sulfite, and it becomes sulfurous acid. So hopefully that's a good review. I will also put a bunch of naming problems on Canvas, and you can practice making sure you know these rules. But basically, if you can identify what the first element is, the rest of the naming is not as challenging because you know which rules you're going to follow for each one.